Hello everyone, welcome to the EasyPower Tuesday Refresher webinar series. Today we're talking about modeling motor starters for medium voltage applications. It's going to be short and sweet, and it really is, I think, some helpful information if you have modeling issues in this particular arena. So welcome all. Our agenda today is based on the recent inquiry from EasyPower users who were trying to model after the current limiting applications for motor starters or contactors, and we use these as according to the application notes, both on motor contactors and transformer feeds. The question was, how does EasyPower reflect the lower rating that's afforded or could be afforded by the current limiting fuses? So with that in mind, let's start with a couple poll questions. So the first question I have is, how often do you use current limiting fuses to increase the withstand ratings of downstream elements? And as always, there's no obligation or liability, but I would appreciate the feedback and your participation in the poll responses. No obligation at all, strictly for my edification. Appreciate everyone attending today. Looks like we have, leave this open another 15 seconds. We're about halfway to a quorum. All right. Okay, we have a little more than half at this point. Okay, let's see how folks have weighed in. So it looks like 70% of the time there's the ability to apply this particular function, and a good minority is using the protection scheme most of the time. So good. The second question is, which do you prefer for motor protection as far as your particular design philosophy? Do you prefer fuses, motor circuit protectors, relays, or some combination of the above? And again, this may vary from project to project or individual to individual, so it's not a right or wrong answer. It's just strictly what your response is on a particular day. So let's give this another 10 seconds. We're halfway to a quorum. All right, thank you. Here's how folks have weighed in. Interesting. Very much what I've seen in the past. Good, excellent. And then finally, how often do you utilize custom data, text, and EasyPower modeling? And this is a feature that we've had in the EasyPower tools now a little over a year, and I don't think we talk enough about it. And that's why I'm throwing it into this this question list. All right, let's see how folks have weighed in. Yeah, so 30% actually aware of it. Excellent. Thank you for participating. Okay, so that brings us to the case in point where the user, EasyPower user, had modeled this motor starting circuit utilizing both a fuse and the switch from Cutler hammer. So let me kind of go through this example and we'll talk about it. And what it amounts to is that based upon the data sheets for the Ampgard series, the application note claims that if we use a Cutler Hammer CL22 400 amp fuse in our circuit, it will afford us a higher protection for downstream devices. So setting this up with an auto calculate, you'll see that we get a response from the EasyPower device library of 40,000 amps. Standoff or interrupting rating. We go in and look at the switch, the SL Ampgard SL series 400 amps, and look at its rating. The data sheet or the device library only shows 6,000 amps protection. If we request it, we can see it's actually getting the numbers from the device library adequately, but it's not the number we're expecting. So what's going on? Well, if we look at the way this is being applied, first of all, if we put in an upstream fuse, or try to put an upstream fuse above the switch on this side of the bus, EasyPower won't let me do that. So that's not a solution. On the other hand, if I manually went in and input the number as far as the protection according to the data sheet, I could do it manually at whatever number that the application note says, but since it's not part of the data sheet, I'm somewhat navigating around the protections that are built into EasyPower. So how does that affect my overall performance? If I zoom out a little bit, well, first of all, let's just do a short circuit calculation. If I go into short circuit, looking at current, fault all the buses, I can see a fault on this downstream bus is going to deliver 24,000 plus amps into my transformer, into this bus. And at a minimum downstream, it's going to be 4,800 amps. So I have protection for a downstream fault, but I don't have protection afforded by that fuse for a fault on the primary of the transformer. And if we go and look at how the actual protective scheme is, again, just to make sure everything's in order, I'm going to go into coordination, plot TCC curves, expand it a little bit. I see my relays doing its thing. The motor circuit, the motor is per setup on the motor. Here's the fuse, the 400 amp fuse, and I don't show any effect. Well, there's no trip mechanism in the switch itself except for the relay. So the relay's tripping the switch. But did anybody notice on my TCC plots, the damage curve for C2, which is this cable down here, isn't really being protected by my protection scheme. So it kind of begs the question, what's going on in my one-line diagram? Well, let me kind of digress from the motor start example and go back to my one line and talk about customized data blocks. I go into database edit. Again, this is EasyPower specific. And I go to my options. I'm going to right click in an open area and go to options. Everyone's aware for text visibility, I need a checkbox in the name block and the data block to show up on my one line. But if I want to customize what's being displayed, I need to go to one line text. And in that, I can customize any particular device or element I want to address. So for my purposes, on a cable size, pretty much when I'm putting together an example circuit, I'd like to know what the ampacity is of the cables as I'm putting them in, just to avoid faux pas. And so what I want to do is include the ampacity in the description when the one line is used for installing a cable. And to do that, I'm going to insert into this location on my data block, scroll down to my ampacity rating, which is right here. Left click and drag and put it in the data block. And just to make it more legible, let's put amps. And as I do that, I see in my example down here that this is the way it's going to show up on my one line. So let's go ahead and apply this. Now I can see that this cable is rated for 260 amps. This cable is rated for 435. And I have a considerable step down in voltage. So I'm curious why I picked the size of this cable as it is. It just could be a downright mistake on my part. Okay, so there's two things I want to get to. One is I need to deal with this ampacity, and second, I want to make sure that we have coverage by this current limiting fuse. Well, the answer ends up being, taking a little different step around, is when we do a equipment duty calculation on the circuit as it stands, we'll find that our switch, the Cutler hammer switch, isn't being protected to the extent that we want. We go into short circuit, fault all the buses, and then look at equipment duty. In spite of it giving me the protection I need or being triggered by the relay, it's going to have its rating exceeded in a short circuit basis. And I can show that or indicate that on my equipment duty report, which shows that the switch itself is being overdutied by some 300%. Okay, so that brings us back to how to deal with the issue. According to the data sheets, another part of the issue is the particular part number and numbering scheme were originally set up by a different company. And when Cutler Hammer was purchased by Eaton, they re-released the data sheets as they were. One of the things you notice on the data sheet is we have an interrupt rating for a fused and an unfused device. And this is true all the way the full voltage range for this particular switch. And what it amounts to is, based on the data sheet, we can apply the series fuse rating as long as it's been tested by a manufacturer and quoted either in a data sheet or an application note. And so if you go to the application notes back in 2020, we requested an update from the Eaton group. And what they reiterated is based upon the combinations of the SL current limiting fuse and the Ampgard starter, we could see protection that gives us considerably better interrupt rating if we do that for this particular device. So in EasyPower, the name of the game is to start off not with a fused switch, but with you want to call it a fused contactor, because the Ampgard switch by itself doesn't have any current protection properties, so it needs the fuse, but it also needs the relay for activation. So that gives us an incentive to go this route. So let's kind of go back and talk about that. So the preferred solution is to go in and instead of starting with a separate fuse and a separate switch, and let me just show you how this is set up. It's the same icon to start with from a fuse switch, but once I put it in the circuit and then open the dialog box, I'm going to select fuse contactor as the device in question, give it the proper name and sizing. So it's a current limiting fuse. Again, I'm describing the fuse. It's a CLE22 that was described on the application note, size 400. And as I do that, I look in the notes and I can see that the reference that's being made to the application note at the particular time. So this is what's covering me for being able to use this. Now, if I did this by hand, if I did this in an override position, I may or may not have that reference to be able to fall back to. So when I get to short circuit calculations, now I have an interrupt rating of 40,000 amps. And just to show that it's part of the data sheet. And then when we go to the switch, we may or may not use the, I'm going to go back and show it set up. Take this guy off. Look how we set this up in the final version. So here's our fuse. Here's our switch designation. Now again, if we don't have auto calculate, it's not going to pull up the number that we have from that data sheet. So I want to do auto calculate in both locations. As I do that, I get my 40,000 amp interrupt rating coverage. Now, when we go back to our short circuit focus, fault all the buses, and look at equipment duty, now we see we have coverage for the contactor itself. And if we go back and look at our TCC plots, I can see I changed. Let me go back to my. So my text was saved with the other project. So I'm going to put it on here. Just to show how it shows up. There it is. So now I see I have a 700 amp capacity now on the cable that I've updated. So then one final check to make sure my timing is going to be good. Go to coordination, plot the TCC curves. Now this also points out, in this case, here's my relay, and here's the motor, the fuse, and transformer. If I fault this bus, I may or may not be able to see my coordination between the relay and the fuse. And part of this is due to having clipping and getting in the way. And so if I go to the relay, actually I need to go to the relay, there he is. Don't clip, go to my settings and set up my instantaneous, some number I want to look at. Now I can set my instantaneous here, and because I don't have clipping, I can see that, in fact, it's not necessarily coordinated because we fall into the vertical column on the fuse. So I want my relay to trip before the fuse and not interfere with the inrush. So I'd say we're in pretty good shape if we have a fault on this bus. Okay, any questions about that? Now this is not mandatory by any stretch of the imagination, but as far as modeling it and have coverage for data sheets, it's kind of the recommended way to go. So the takeaway, and part of this is a sign of the times where companies are buying other companies, and we may or may not have the updated part number scheme and the device library. Don't spend more than 5 minutes trying to look for a part number that doesn't seem to be where you think it should be. Utilize support at EasyPower.com, especially if you have questions regarding the device library. We have an excellent engineer who works full-time keeping the library up to date. And if you find or think you've found a part that's not in the library, by all means, send a data sheet or a request to support at EasyPower.com and have it updated, and you will get a response with a improved model within 48 hours. And then likewise, make sure any questions regarding unique modeling issues, just as we walk through, can be easily covered with an email or a call into support at EasyPower.com. And just as a personal item, consider advantages of custom data block in applications that you may or may not want to use all the time. You can save a particular configuration and use it only for some audiences or not use it at all. Thank you all for attending today. By all means, keep track of the EasyPower newsletter. There's there are a lot of considerations to the licensing options that are taking place now, so you may want to check it out. And we look forward to joining you on webinars in the near future. Have a good day.